This video is going to cover the topic of gross premiums from contingencies in actuarial mathematics. And I'm going to break down gross premiums into two videos. So this first video is going to cover gross future loss random variables. And the second video will be with respect to calculating premiums that satisfy probabilities. Okay, so the gross future loss random variable is a random variable, and so it's a function of the lifetime of my policyholder. That's where the randomness comes in. And it's a future loss random variable, so future because I must present value this loss that's potentially going to occur in the future. And then it's a loss random variable because I'm calculating it by taking the present value of the outgo minus the present value of the income. Okay, so if I were to calculate profit, that would be present value of income minus present value of outgo. But this is a gross future loss random variable. Okay, so I take the outgo minus the income. Okay, so let's first deal with a whole life assurance contract. Okay, so here we have whole life assurance. Okay, so the gross future loss random variable, I'm going to denote that as L, will be equal to SV to the TX. I'll explain all of this in a moment, plus I, plus E A bar TX, plus F V to the TX, minus G A bar TX, where Okay, so what I've essentially done here is I've taken my benefits and my expenses and I've subtracted from these outgoes of benefits and expenses my income, which is my premiums. Okay, and all of this has been present valued. Okay, so my benefit payment will be the sum assured value of S at time Tx. So when this person dies after Tx number of years, where Tx is the complete future lifetime of a life now aged X. Okay, my capital I here is initial expenses, so there's no time value of money that I must factor in for this because it happens immediately, so I don't present value that by a factor. And then, or rather just the factor that I present value this by is 1. Okay, then my renewal expenses, I'm going to assume for this scenario are payable continuously. And also, by the way, I assume that my benefit payments for this whole life assurance are payable immediately on death. I could have assumed that benefit payments were paid at the end of the year of death, in which case Tx would have been Kx plus 1 in this term over here. Okay, as well as this term over here. And this F here represents the terminal expenses, so expenses that we incur when the contract terminates, so when this life dies. Okay, and I said this was a continuously payable annuity for the lifetime of this person, and so I will continue to incur this renewal expense at a rate of E per year until this person dies. Okay, so until Tx runs out of time. Okay, and then this is my terminal expense. It has the exact same discount factor as my sum assured, my benefit that gets paid to the policyholder. Why? Because I incur this expense at the same time that they die, which is the same time that I must pay them out the sum assured. Okay, and then here is my gross premium, the present value of the gross premium. Okay, so I'm now assuming, for the sake of writing this formula, that my premiums are payable continuously for the lifetime of this life now aged X. So that means I must have a continuous annuity and the term must be Tx. Okay, and the size of these payments is G, which is the gross premium, represents the gross premium. Alright, simple enough. Now let's move on to endowment assurances. Okay, so for the gross future loss random variable of an endowment assurance, it'll take a very similar form to above, except for the fact that I'm going to be changing that Tx to be a m, and I'll explain to you what m is. So m equals the minimum of Tx and n. Okay, so we understand why it takes this form because I've explained this, but why now am I using m to be the minimum of Tx and n instead of just Tx like I did for whole life assurances? Well, now that I'm dealing with endowment assurances, my death benefit should be paid either on death during the term, Tx, or on survival to the end of the term, n, whichever one happens first, which is why I take the minimum. Okay, my initial expenses are no different to the whole life assurance in that they'll be incurred at the start of the contract regardless of whether this person dies or survives. Okay, then my renewal expenses will terminate either on the death during the contract or on survival to the end of the contract. Now, whichever one happens first determines the termination of this contract, and so I take the minimum of those two. And I do the same for all of these things, and the similar logic just applies all the way through. Okay, so I'm not going to continue saying the same thing. Okay, now I said that if death benefits were payable at the end of year of death, I would have replaced Tx in these two formulas for those terms, and for those terms, I'll replace the Tx with Kx plus 1. Okay, why do I do that? Well, because if it's now not payable immediately on death, but rather at the end of year of death, then if this person survives for Kx whole number of years, then it should be paid at the end of that year of death. So if they survive for 5 total years, so in other words die within the 6th year, they'll be paid at the end of the 6th year. And so Kx plus 1 would be 5 plus 1, which is 6. So I must discount it by 6 years. Okay, now if my premiums and regular expenses were payable annually in advance instead of being payable continuously throughout the contract, then I'm going to be replacing Tx with Kx plus 1 for similar reasons why I replace Tx with Kx plus 1 for death benefits that are payable at the end of year of death. But I must also replace A bar with A dot dot over here and over here. Okay, so why must I do that? Well, because now it's not payable continuously. It's payable annually in advance. And so that's the annuity that I'm dealing with. Okay, so those things are simple enough, but definitely worth mentioning. Okay, now what happens if we are all of a sudden at a different time in this policy and I want to calculate the gross future loss random variable for an in-force policy for the rest of the contract term? So now I'm saying, what if we're at t equals to some number? So let's just say, what if we're at time t? Okay, then I must replace this m here. I'm going to do it for the endowment assurance. So then m becomes the minimum of Tx plus t and n minus t. Okay, so let's understand this. Why do I do this? Well, here you go. Here's the life now aged x, or aged x at time 0 at the start of the contract. And here's time t. So this person aged x plus t. Okay, so I'm now looking from t onwards until the end of the contract, and I need the gross future loss random variable. So this death benefit now should be payable when this person dies, yes, or at the end of the contract, yes, because it's an endowment insurance contract. But now I'm not going to be present valuing it by these extra T years. I'm going to be present valuing it to where they are aged X plus T at this current point in time, which is at time T. Okay, and so I must discount it by Tx plus T. Okay, and this T here should be in that subscript there. Okay, so why is that? Well, I'm doing this for the complete future lifetime of a life now aged X plus T. Okay, and the complete future lifetime for now a life aged X plus T is different to a life aged X. Okay, and so I must discount it by T X plus T years. Okay, but if they survive until the end of the contract, where the contract has n number of years in it, but we're already T years into the contract, then I only have to discount it by the remaining n minus T years. Okay, and then the other thing that I'll change is, so what if we're at time T, then this simply changes. It remains exactly the same, except I change this M to this, and I also remove this initial expense. Why? Because I'm beyond that. The gross future loss random variable doesn't have an initial expense in it. The initial expense is in the past, not the future. Okay, now this is going to be, this next thing I'm going to talk about is for sure the most complicated part of this video, so try pay attention. I'm dealing with profit policies. And by the way, if this is difficult to understand or you're not understanding, then just leave a comment down below and I'll try my best to tend to it. Okay, or to clarify whatever was not clear enough. Okay, so I'm going to use an example with specific numbers in this particular explanation because it's going to help clarify things a lot, so we can remember what I'm dealing with. Okay, so my gross future loss random variable, L, is going to be equal to, or my future loss random variable will be equal to 20,000 plus, I'll explain all of this, 2,000 times by the minimum of K 40 and 19 V to the minimum of K 40 plus 1 and 20 plus 150 minus 2450 a dot dot min of K 40 plus 1 and 20. Okay, that's good enough. Okay, so you'll notice immediately that this sum assured value, the coefficient of my present value factor for my benefit payment, is different to above, which is the essence of this thing because it's a with profit policy. And you'll also notice that, so my initial expense is still here, but you'll notice that my terminal expense is gone and my renewal expenses have gone. So the reason why they've gone is because it's not important to illustrate the difference, because my terminal expense will just have that there and my renewal expenses will have the same factor as my gross premiums, depending on the wording, but easy enough to figure out. Doesn't change because it's a with profits policy is what I'm saying. Okay, so let's understand this. Alright, so what I'm saying here is that the person is now aged 40. The term of this contract is 20 years. And each year, the sum assured will increase by 2,000 Rand. And they also have an annual premium of 2,450 Rand and an initial expense of 150 Rand. Okay, so This sum assured starts off at 20,000 Rand. Then if this life dies within the first year, in other words, K40 equals 0, then I'll take the minimum of 0 and 19, which will be 0, and I'll multiply it by 2,000. 0 times 2,000, 0. So my sum assured for the first year is 20,000. In the second year, this person begins the second year age 41. If this person dies in the second year, then K40 must be equal to 1. Okay, so the minimum of 1 and 19 is 1. So it's 1 times by 2,000 plus 20,000, which is 22,000. So in the second year, the sum assured is 22,000. And you can see how this now, if you follow that logic, the sum assured will increase by 2,000 each year, and it starts at 20,000 in the first year. Okay, so we understand that bracket. Now I'm discounting this by the minimum of K40 plus 1 and 20. So the 20 is simple enough to understand. This is a with profit endowment assurance policy. And so if this person survives to the end of the term, then I must discount it by 20 years because the term is 20. But if they die within the term, and this is the sum assured is payable at the end of year of death, then I must pay them after the number of whole years of life that they've had, plus the year that they died in at the end of that year. So if they died in 5.5 years' time, they had 5 years, whole years of life left. So K40 would have been 5. Then they get paid at time 5 plus 1 is 6 at the end of this year of death at time 6. Okay, so we understand that. 150 we understand, that's the initial expense. Now this we understand, similar reasoning to that there. Okay, now I'm going to complicate this a bit more. What happens now if I am dealing with a policy that is in force? Okay, so what happens now if I am at just before the 10th premium is paid? Okay, so what happens now? Similar scenario to above here if we're at time t, but now I'm saying I'm at the point in time just before my 10th premium is paid. So if my premiums are paid in advance, this means I'm at time 9, but just before the premium is paid. So at time 8.99999. Okay, that's where I'm at. I'm sitting just before that premium is paid. Okay. Now, the way that this differs is as follows. So I'm going to write down the future loss random variable and then explain the difference. Okay, so L will be equal to 36,000 plus 2,000 min of K49 plus 1 and 11 times by V to the min of K49 plus 1 and 11 minus 2450 a dot dot min of K49 plus 1 and 11. Okay. Alright, so immediately notice the difference between these two. I have lost this initial expense. I've lost the initial expense because I've passed the initial expense. I'm now at time 9, just before the 10th premium is paid. So the initial expense is in the past. Don't include it in my future loss random variable. Okay, but now you notice the things that have changed is pretty much everything else. Okay, so this sum assured amount has changed to be this. Now, you can write this in another way, which I'll explain in a moment. But why is it this? Well, let's think about it. Just before the 10th premium is paid, I'm at time 9. Now, at time 9, so let me draw a timeline to illustrate what I'm talking about here. Alright, so here's the start of the contract, time 0, age 40. Then at time 1, age 41. Here, if they get paid, they'll get paid 20k. We decided that was true when I explained this formula. And then if they die aged 41, they get paid out at time 2, and the payment is 22,000, and that goes on. But now I'm sitting at time 9. Okay, so at time 9 is just before the 10th premium that occurs right over there. Okay, now I need to find out what the sum assured would be. Okay, well, if it starts out at 20,000 at time 1, it must increase by 2,000 for each increment in these years. So by the time this 10th premium is going to be paid, so at time 9 here, what is going to be the amount of the sum assured? Well, it would have increased, or rather, let's look at it at time 10. So at time 10, it would have had 9 increases. So why would it have had 9 increases? Because it started at 20,000, then it went to 22,000 at time 2. So at time 2, it had 1 increase. At time 3, it'll have 2 increases. So at whatever time, it has time minus 1 number of increases. So at time 10, it has 10 minus 1, 9 increases. Okay, 9 increases of 2,000 Rand is 18,000 Rand worth of increases. So 18,000 plus 20,000 is 38,000. So I'm expecting the sum assured here to be 38,000. So that means, working backwards, that would be 36,000, and that would be 34,000. Okay, so why then does this make sense? Well, because if this person, now aged 49, dies within this year, so K49 equals 0, then I'm going to take the minimum of 0 plus 1 and 11. 0 plus 1 is equal to 1. 1 is less than 11, so the minimum is 1. So I have 1 times by 2,000 plus 36,000, which is 38,000. And what do you know? I have 38,000 over here. So I can rewrite this, so we know this is true here. Okay, and if you're skeptical and you want to apply it for later years as well and see if this is true for K49 being some other value, then you can do that. But you'll see that it's right. Okay, so the other way to write this is I could say 38,000 plus 2,000 times by the minimum of K49 and 10. Okay, instead of this brackets. And I'll keep this coefficient the same here because all I'm changing is the way I'm expressing this number. These two things are equivalent, and so I don't need to change this coefficient. Okay, so I'm changing this here. Okay, so, and by the way, I'm going to explain this in a moment as well, as soon as I've finished explaining why this is also right. So let's take K49 to be 0 again. Okay, so this person dies aged 49. That means that I'm taking the minimum of 0 and 10, which is 0, and then 0 times by 2,000 is 0, plus 38,000 is 38,000, which is the same as this amount here, which is the same as what I got when I plugged K49 equals 0 here. So those two things are equivalent. Okay, makes perfect sense. Okay, now this here changes because just before the 10th premium is paid puts me right over there at time 9. Now, if this person dies, then I'm going to be paying them at the end of year of death. So if they survive for K49 years, whole years, then I'll pay them at K49 plus 1 at the end of that year that they die. Okay, but if they survive to the end of the term, then I must present value it from the end of the term to time 9. And 20 minus 9, because this contract has a term of 20 years, 20 minus 9 is 11. Okay, so I'm going to be discounting this by 11 years if they survive. Okay, so we understand that term now. Now we need to understand this term. Okay, it's pretty much the same explanation that I used there for why I use that. All right, instead of this here. So I don't need to explain that. All right. Okay, now this next part is also quite complicated. I think a little bit more complicated. Okay, now what happens if bonuses are vested at the end of each year, but now here's the catch, including the first year. So that's the difference. So bonuses here are vested at the end of each year. We can see that this is true because it increases each year, the sum assured amount. But now what happens if the increases also must happen within the first year? So what I'm then saying is that my base sum assured will still be 20,000, yes, but if this person makes it to the end of the first year, then I'm going to make this increase now within this first year, and then the sum assured at that point in time is 22,000. But if they die within the first year, they're still going to get 20,000, but it increases in this first year. So the only real difference that we see is not on death. Okay, why is it not on death? Well, because if this person dies here, yes, I'm going to increase the thing, but only if they didn't die, I would be increasing it. So the bonuses are vested at the end of each year, including the first year, but if they die, it didn't get to increase. So I'm still going to be paying them that 20,000. Now, then, if they do survive this first year, then it would have increased to 22,000. And the next increase that could happen is at the end of the second year. But if they die, they won't receive that increase, they'll still receive 22,000. So everything seems to appear the same. Everything seems to remain the same, but the difference is on survival to the end of the term. So if this person now survives to time 20, okay, then they wouldn't have received 19 increases in the sum assured, they would have received 20 increases in the sum assured. Why? Okay, the reason is because initially I'm saying it starts at 20,000, it goes to 22,000 here, and it just increases. And it increases by the time period minus one number of times at that particular time. That's how many time periods it's increased by. So at 20, it's increased by 19 times. Okay, but if these bonuses are vested at the end of each year, including the first, then technically that becomes 22,000. The sum assured at that point is 22,000. So it happens, the first increase happens in the first year, second increase in the second year, third increase in the third year, 20th increase in the 20th year. 20 increases now, not 19. Okay, and the difference is that I'm including bonuses from the first year. They vest from the first year, from the end of the first year. Doesn't affect my death benefits, but it does affect my survival benefit. Okay, so what's the difference then? So my L0, my future loss random variable at the beginning of this policy at time 0, will be equal to 20,000 plus 2,000 times by the minimum of K, 40 and 20. Shucks, this is going to be a long video. Okay, after I've done L0, and then I'm also going to do L9, similar to how I did here. Those won't take too long. Then I'm just going to explain a term assurance policy quickly, and that'll be the end of the video. Okay, this is all important that I'm doing now, so make sure you're listening to this. Okay, so this multiplied by V min K40 plus 1 and 20. Okay, and then the rest of the contract. Okay, but here's the important difference. So I'm only going to deal with this part of the future loss random variable. Okay, so this 20,000 stays the same that it did over here. 2,000 minimum times by K40, 19. The difference has been that 19 turned into 20. And this payment, the time that the payment occurs, so how much I must present value by, remain the same. Why? Because the payments still happen at the same time. So the only difference here is that the 19 turned into a 20. 19 turned into a 20 because on survival, they will be receiving 20 increases to the base sum assured, not 19, as was the case before. Okay. Then L9 will be equal to 38,000 plus 2,000 min of K49 and 11, and then here V min K49 plus 1, oops, and 11. Okay, etc. The rest of the contract. Okay, now the difference here. Okay, so I've kept the. I'm now using this top formula. So the 38,000 is the same. The 2,000 is the same. K49 is the same. The only difference now is 10 became 11 for the same reason that 19 became 20. Okay, and then here is the exact same as this for the same reason that this is the exact same as this. Okay, so no extra explanation is needed. All right, now briefly before I end this video, term assurance policies. Future loss random variables for term assurance policies. Okay, so my future loss random variable will be equal to SV to the TX plus my initial expense here plus my renewal expenses payable continuously for the lifetime plus my terminal expenses minus my gross premiums that are payable continuously for this lifetime. And this is actually a piecewise function. Okay, I'll define the ranges now for TX. Okay, this is where Tx is less than n, and this is where Tx is greater than or equal to n. Okay, now quickly note that you can't condense this term assurance policy into one line. You can't do that. You have to write it as 2 lines in this case. And before I explain how this works, which it's not that complicated, but before I explain how it works, let me say that it's very important that you know how to write up these future loss random variables from scratch. Okay, so you might be given a contract or a policy in qualitative terms, in words. They'll explain to you this contract. Premiums are paid in this way, death benefit this way, it could be increasing, whatever. It's explained in words, and then you have to go and write the future loss random variable. And that question usually precedes calculating premiums that satisfy probabilities, which is the subject of the next video that I'm going to be doing. And it's extremely important that you are able to do this and that you can get this right, because it carries a lot of marks. Okay, maybe not easy marks, but it's all or nothing pretty much. Maybe not, okay, that's maybe a bit harsh, but you lose marks quickly in this section if you get something wrong, because it means that you've missed something fundamental, and so you probably made a mistake in your TX somewhere or in the term of the contract, which means all of your things are going to be off in terms of the term of the contract. And then it means that the next question is going to be off if you're calculating premiums that satisfy probabilities, because you're dealing with the wrong future loss random variable. So you need to make sure you get this right. Okay, so practice this a lot. You can find questions on your Actuarial Society's websites. Okay, so back to the term assurance policies. Now, term assurance policies is the same like the endowment policies, except I'm not paying on survival to the end of the term. So I've now subbed out my M back in for TX as I did for whole life assurances. But now, instead of whole life assurances where it must pay for eternity, I'm capping this and I'm only giving them cover until the end of the contract, which is N years. So if they die within N years. Now, if they die within N years, their whole lifetime, complete future lifetime of this life now age X is less than N, then it looks exactly the same as my whole life assurance did. Okay, but if they survive for longer than N years, they don't die within the term, then there is no benefit payment. There is no terminal expense. But I still did incur the initial expense. I still did incur renewal expenses. And I still did receive premiums for the term of this contract. Okay, that's it for this video. I hope you enjoyed it. I hope you found it useful. If you have any questions, leave it in the comments below. I'll see you in the next one.